Good afternoon, everyone. Today, I would like to talk about the 2016 Nobel Prize in Physics. I chose this topic because it introduces a new way of understanding matter based on topology. The prize was awarded for theoretical discoveries of topological phase transitions and topological phases of matter. Traditionally, phases of matter are classified by symmetry and order. For example, solids, liquids, and gases are distinguished by how their particles are arranged. However, this discovery introduced a different perspective. It showed that some properties of materials depend not on local detail, but on global structures. This idea comes from topology, a branch of mathematics that studies properties that remain unchanged under continuous deformation. For example, a coffee cup and a donut are considered equivalent in topology, because both have one hole. In certain materials, electrons behave in ways that are protected by topological properties. This means that their behavior remains stable even when the material is disturbed. Such materials are called topological insulators and superconductors. These materials have unique electrical properties and may be useful in future technologies. This discovery has opened a new field in physics. It has changed how scientists classify and study matter. I find this discovery very fascinating because it shows that structure can determine behavior in unexpected ways. It also teaches us that global patterns can be more important than local details. In the future, this research may lead to new technologies, including quantum computing. Even though this topic may seem abstract, it gives us an important message. The shape of a system can define its function. Thank you.
Good afternoon, everyone. Today, I would like to talk about the 2016 Nobel Prize in Chemistry. I chose this topic because it shows how scientists can build machines at the molecular level. The prize was awarded for the design and synthesis of molecular machines. A molecular machine is a system made of molecules that can perform controlled movements. At first, this idea may seem unusual. When we think of machines, we usually imagine large devices like engines or robots. However, scientists have succeeded in creating machines that are only a few nanometers in size. These molecular machines can rotate, move, or change shape in response to external stimuli. For example, some molecular structures act like switches that can turn on and off. Others behave like tiny motors that rotate in a specific direction. These movements are controlled by light, heat, or chemical energy. This discovery is important because it represents a new stage in chemistry. Instead of only studying molecules, scientists can now design systems that perform functions. This opens up new possibilities for nanotechnology. In the future, molecular machines may be used in medicine, such as targeted drug delivery. They may also lead to the development of new materials and technologies. I find this discovery very fascinating because it shows that even at the smallest scale, systems can be engineered. It also teaches us that function can emerge from carefully designed structures. In the future, this field may grow and lead to practical applications. Even though this topic may seem futuristic, it gives us an important message. Small systems can perform powerful tasks. Thank you.
Good afternoon, everyone. Today, I would like to talk about the 2016 Nobel Prize in Physiology or Medicine. I chose this topic because it explains how cells recycle their own components to survive. The prize was awarded for discoveries of mechanisms for autophagy. Autophagy is a process in which cells break down and recycle their own components. At first, this idea may seem unusual. However, it is essential for maintaining cellular health. Cells constantly produce proteins and other structures. Over time, some of these components become damaged or unnecessary. If they are not removed, they can harm the cell. Autophagy solves this problem. The cell forms a membrane structure that surrounds the unwanted components. This structure is called an autophagosome. It then fuses with a lysosome, where the contents are broken down and recycled. This process allows the cell to reuse materials and maintain balance. Autophagy is especially important during stress, such as starvation. In such conditions, cells recycle their components to generate energy. This discovery has had a major impact on biology and medicine. It is related to diseases such as cancer and neurodegenerative disorders. Understanding autophagy may help develop new treatments. I find this discovery very fascinating because it shows that cells can manage their own internal resources. It also teaches us that removing unnecessary elements is essential for survival. In the future, this knowledge may lead to advances in medicine and health. Even though this topic may seem complex, it gives us an important message. Recycling is a key part of sustaining life. Thank you.